So today, we're going to graduate from simple inequalities to compound inequalities. So compound inequalities, the word compound just means when you put things together, right? So a compound inequality is just two inequalities joined together. That's it. There are two types of compound inequalities, or and inequalities, and they mean different things. And let's illustrate that for a second. Think about the word or. So I'm going to ask you a couple questions here. Raise your hand if you have a pet dog or a pet cat. A lot of hands go up, right? Most hands in the class. Raise your hand if you have a pet dog and a pet cat. Okay, only a few. You see the difference, right? An or statement is true if either one of those things is true. They don't both have to be true, right? An and statement, though, requires all of the statements, both of them, to be true, right? So there's a big difference between the words or and in math. An or compound inequality, we call that a disjunctive inequality. That's not really important, but the big thing is it's a union of the graphs. I'll show you what that means. The words union and intersection get tied to these two different types of inequalities. Or goes with the word union. We live in a union of states. That means all of the states are just added together, right? When we talk about an or inequality, this is an example of the graph of an or inequality. This is the graph what we're graphing. This symbol, by the way, in math we like to use symbols. That's our math symbol for or. It's kind of like a capital V. That stands for the word or. So this just says x is less than or equal to -4 or x is greater than 1. Okay, well, what do? We just graph both of those. If we graph the blue inequality, x is less than or equal to -4, isn't it just that one right there? Yeah. Right? We got a closed endpoint at -4. Why is it closed? Everybody, why is that closed? Okay, because it includes equals, right? Includes equals, so it's closed. And we want the values less than, meaning left of, -4, so that's it. X is greater than 1, well, that would give us an open endpoint because it does not include an equal sign, and we want the values greater than or to the right of 1. Well, the or inequality just graphs everything. You just add all the graphs together, so we get both of those combined is our or inequality graphed, right? Our compound or inequality. How do you recognize that? I'm always looking for ways to help you kind of make these connections. Here's an easy one. The graph of an or inequality usually looks like this, and that's like somebody's rowing a boat towards you, and those are the oars sticking out the side of the boat. Okay, and there's the two oars, blue oar and a red oar. So we graph both of those at the same time. That's what a union means. Everything just gets added together. If we want to write this with interval notation, it makes sense that the blue part of the graph would look like this, wouldn't it? Comma goes in the middle. What's the left endpoint of the blue part of the graph? Everybody agree? It goes out to the left forever. And infinities always go with parentheses or brackets? Parentheses. The right endpoint of the blue graph? Everybody? Let's get everybody involved here. What is it? What's the right endpoint of that? -4, right? An ant can only walk on the blue section to the right until he gets to -4, and then he's stopped by the endpoint, right? And we'd use a bracket. How come a bracket? Why a bracket? What's going on here? How come a bracket? Casey, why do we have a bracket here instead of parentheses with this one? Closed circle, closed endpoint, good. And then the red one, what would that look like? So we'd have our comma in the middle, left endpoint. What's the left endpoint of the red graph? +1, good. Right endpoint, infinity. And we get parentheses on both sides because that's an open endpoint, right? Okay. All right, so we just write both of those joined together with an or symbol. Now notice, we do this a lot in math. Notice that the or symbol changes for interval notation. Okay, we always do stuff like that. There's a reason for it though. But here's an easy way to remember it. That the V goes with inequality notation, and the U goes with interval notation. And by the way, if we want to label these, we would say the first one is written in inequality notation because we're using inequality symbols. That's it. Remember what notation means. Notation just means a way of writing something. Like in Mr. Cooper's class, if you use scientific notation, that's just a different way of writing numbers, right? That's compatible with really big or really small numbers. Okay, so that's all notation means. Inequality notation with inequalities. You can remember that the symbol for OR is a V because you tell me, what happens if I take that V and I tip it on its side? What does it look like? What's it look like if I tip that thing on its side? Yeah, greater than or less than. It looks like an inequality symbol, doesn't it, right? So that's easy to remember. That one tipped over looks like an inequality. The OR that we use for interval notation, if I take that U-shaped thing and I tip it on its side, what does it kind of look like? Parentheses, yeah. Okay, so it's easy to keep those straight, right? Okay, so that's how we write OR compound inequalities. Some textbooks will use a slightly different notation. They'll use a comma instead of the U sometimes. So just make sure, like whenever you guys are doing questions in my math lab, remember that all the work needs to be done in your math notebook. The work is important. That's only for entering answers. It's a good idea when you're entering those answers. Always look at the little blue writing that's in parentheses next to the answer box. And it tells you what kind of answer they're looking for. So sometimes they'll say things like, enter your answer as an integer or simplified fraction. So would a decimal be okay? No. It wants a fraction. If they say, enter your answer as a decimal rounded to 2 places, then make it a decimal. That's how they want it. But sometimes they'll want commas and sometimes they'll want U. So just be aware of that. Okay, let's look at an example. If we want to actually solve one of these, an OR compound inequality, how do you think we do this? I've got this. This is the statement. I've got this inequality on the left or this inequality on the right. How do you think I'm going to tackle that?
Solve both.
What do you mean solve both? What's your strategy here? Where would you start with this?
Solve for x.
Okay, in which one? Okay, so the point is we can do them one at a time, right? We're just going to tackle these individually, do each one separately, and when we're all done, we'll combine the answers, right? So let's take this first one. If I'm trying to, just like I would with an equation, I'm trying to isolate the variable on the left side this time, right? So what are the steps I'm going to have to go through to get that x by itself? What's the first thing I'd probably do? What do you think? What am I going to do first here? What am I going to do? Great idea. Multiply by -3. How come? Well, I've got to undo dividing by -3, right? Multiplication and division undo each other. So we're going to multiply through by -3. So if I distribute that, when I distribute to the first term, all it's going to do is just cancel that -3 on the bottom. That was our goal, right? And we just end up with 8 minus x. How about if I distribute it to the other side? What do I get? 15. Anything I need to be aware of here with the inequality symbol? Okay, but the rule was, remember from yesterday we reviewed this? The rule is if you have an inequality, equations you don't have to worry about this, but with inequalities, if I multiply or divide both sides by a negative number, what do I have to do to the inequality? You got to flip it, absolutely. Okay, so because of this negative sign, the inequality gets flipped around. Okay, give me thumbs on that. Is that making sense? Okay, that's a really simple one to miss. People oftentimes forget that. Okay, we're making some headway. What's next? Got to get that x by itself. Next step would be subtract 8, wouldn't it? So we subtract 8 from both sides. Those go away. I get -x, 15 minus 8 is 7. And I don't flip anything, right? Because I haven't multiplied or divided. I just subtracted. And then last step. Divide by -1. Good. Divide. Which, by the way, Dividing by -1 is exactly the same thing as multiplying by -1. They both do the same thing. If I multiply or divide both sides of an equation by -1, what does it do to all the terms? Just changes the sign, doesn't it? Makes positive, negative, and negative, positive. So what I like to do, to me it's just easier to show multiplication than division, so I always just do that. When I distribute the negative, it makes this negative x positive. It makes the 7 into a -7. And what do I have to do? Got to flip the symbol because I multiplied or divided, whichever one you want to do, by a negative. So there's part of my solution. X is less than or equal to -7. Okay, give me thumbs on that part. How are we doing? Okay. Other side. We'll make this one red. So I'm trying to isolate this x. What's my first step? Okay, great idea. Let's clear fractions. Let's multiply by 2. I like that. So if we distribute that 2, I'm going to get, what, 10 minus, it's going to cancel the 2, isn't it? I'm going to get 10 minus 3x is less than -2. Agreed? Okay, good. We got rid of fractions. Now what? What's next? Okay, good. I'm going to subtract because I'm using inverse operations, right? So if I look at PEMDAS, I'm isolating, so I have to do addition and subtraction before multiplication and division, right? Good. So we subtract 10. And that gives us -3x is less than -12. Last step? Divide by -3. Good. Which cancels the -3's. So I get x by itself. And what do I have to remember to do? Got to flip the inequality because I divided by a negative. So that flips to greater than, and -12 divided by -3 is +4. So then there are my two parts. X is less than or equal to -7, or, which I use an or symbol for, or x is greater than 4. So everything in the box is my solution. Okay? Let's graph that. The blue one. How do I graph the blue part of that compound inequality? Closed endpoint at -7, and I'm graphing to the point, yep, to the left. Good, because I want less values, okay? How about the red part? Open at 4, graphing to the right. Okay, there's my graph. So now it's easier, you've probably noticed this, it's way easier when you want to write something using interval notation to just use the graph, right? Because the graph corresponds to interval notation. So what's the blue part of the graph going to look like? I got my comma in the middle. What goes on the left? -infinity, because that one, the left end point of the blue part of the graph is out at -infinity. That goes with parentheses. What's the right end point? With brackets. Okay, how do I say or with interval notation? Ah, good, good. It's that, isn't it? It's the U-shaped one. And then the red guy is going to look like comma. What goes to the left of the comma? 4 with parentheses, because it's open. Good. And to the right? Okay, good. Got it? All right. The other kind. So now the next kind is, so we did or. Here's and. So and is conjunctive. It's a conjunctive inequality. Again, not super concerned, you know that name, but someday you'll see it again, and it won't be the first time you see it next time, right? At least you've seen it once. Okay, and inequalities graph the intersections of the graphs. So let's take an example. Let's take one like this. Okay, notice that the symbol for and is, we just take an or symbol and we flip it upside down to make it and. Okay? So this says x is greater than or equal to -2 and x is less than 5. Okay? If we graph those separately, would you guys agree that the blue one would look like a solid endpoint at -2, and then we would graph to the right forever?
Yes.
Agreed? Okay, the red one would be an open endpoint at 5, and we're going to graph to the left forever.
Yeah.
But and inequalities are where both of the things are true. So we're only looking for the overlapping parts of the graphs where they're both graphed at the same time. Where would that be? Where's the intersection of the red and the blue where they overlap? How would you describe that? Where is that? Okay, -2 up to 5. Yeah, exactly. Okay, so it looks like this. We had our blue endpoint and our red endpoint, but the and inequality is only going to graph the overlapping region between the endpoints. Okay, so look at what an and inequality looks like, a compound and inequality. Instead of having oars on a boat that extend out forever, it's got one smaller interval with endpoints on both sides. Okay, that's kind of what we should expect those to look like, except in some weird cases. Okay, this is fine. We can write these separately, but we don't like to at all. There's a much better way to do it. If you think about the way this thing is written, the and inequality is all of the x values that are greater than -2 and less than 5, right? Does that make sense? It's the ones that are pinched in between those endpoints. And so we like to write it like this instead. We write it like that. We write it as a 3-part inequality. Compound and inequalities go with 3 parts, where the variable goes in the middle, and it's greater than, or in this case, greater than or equal to the bottom endpoint and less than the top endpoint. Okay, and the way we would say this when we're talking about a condensed form like a compound and inequality that we push together into one triple inequality, the way we would read this is not from left to right like a book. We always start in the middle. We'd say x is greater than or equal to -2. So we read it to the left first, and then we read it to the right. X is greater than or equal to -2 and less than 5. And you can see that both of these inequalities are contained in that one statement, right? There's the first inequality. X is greater than or equal to -2. Well, we said that right there. X is greater than or equal to -2. We just read that one backwards. And the other one, x is less than 5, is the second part of that, but we just smush them together so it's more efficient, right? Okay, you guys have seen stuff like this? Give me 1 to 5 on how much of this you've done in the past. 5 meaning you've done a lot of this. 1 meaning I've done none of this. Okay, so quite a bit. That's good. That's good. All right, so what about interval notation? Interval notation is super easy with and inequalities. You guys look at that interval and tell me, comma goes in the middle, what's my left endpoint of that graph? -2 with parentheses or brackets? Bracket, because it's closed endpoint, right? So we get that. To the left of the comma, what's the right endpoint? +5 with parentheses because it's an open endpoint. Look how easy it is to write and inequalities with interval notation. Very simple, okay? All right, let's try 2 of these for practice. So here's one that's actually written with the word and. Usually we'll do this kind. Usually we'll start off with an inequality that's already in 3 parts with the variable in the middle. Usually we do that. Sometimes we do this. We use the word and. That's fine. We would just do these individually and then combine the answers together when we're done, just like we did with or. Okay, this is a pretty easy one. What are the 2 steps to isolate x in the blue inequality? Subtract 3 and then divide by 2. Everybody agree? Okay, so we subtract 3. We get 2x is greater than what? -12. You guys told me divide by 2. That's correct. Now we're dividing by a positive, so we don't flip any signs. So we get x is greater than -6. How about the red one? I want the two steps in order on the red one. Spencer, what do you think? What do we got? What's first step? Add 2, perfect, and then? Excellent, that's what we do. So we add 2, we get 8x is less than 32, divide by 8, and we end up with x is less than, what, 4? And we'll connect those with our and symbol. But we don't want to leave it like that. We want to try to push these together. When we want to write these as a 3-part inequality, the easiest way to do it would be to graph it first. The graphs are very helpful. So would everybody agree the blue one is going to be open endpoint at -6, and we're going to shade to the right, aren't we? Graph, because we want greater values, so we're going to do that. The red one is going to be open endpoint at +4, graphing to the left. So what's the overlapping region going to be then? -6 to 4, exactly. So it's going to look like our endpoints are open at -6, open at 4, and we'll just connect everything in between. Right, so then if we write that using interval notation, it's easy, right? Comma goes in the middle. What goes to the left? -6 with parentheses. And on the right, we get 4 with parentheses. And if we want to write this as a 3-part inequality, it looks the same. The x goes in the middle, right? What is going to be to the left of that? X is greater than what? Aha, greater than -6 and less than 4. So everybody sees then how, whoops, those go together, don't they? Right? Notice that when we write that 3-part inequality, we always want to, the inequality signs always open to the right, because we want to have smaller numbers on the left and bigger numbers on the right, just like our number line, okay? All right, so let's look at one like this then. This time we're starting with the x in the middle of a 3-part inequality. Don't let that intimidate you. All you do is just do the same thing to all 3 parts until you get the x by itself. What would the first step be to try to isolate this x? Multiply everything by -2. There you go. So we'll distribute that to all 3 parts. Everybody agree -2 times -5 is +10. When I distribute to the middle, it's just going to cancel that, right? The denominator. So we get 12 minus x, and -2 times -2 is +4. Anything I need to be careful about here? Got to flip the signs. Good, because I multiplied by a negative. So these guys get flipped. Okay, what's next? What's next here? What do you think, Omar? What am I doing next? Got to get that x by itself. Yeah. Subtract 12. There you go. So those guys cancel. Good. 10 minus 12 is -2. I get a negative x in the middle. 4 minus 12 is -8. Okay, last step, everybody. What's that going to be? Divide or multiply. I'm going to multiply. Just easier to show. So I'm going to distribute the negative all the way through, and that's going to give me +2. It's going to give me positive x, and it's going to give me +8. And what does it do to the inequalities? Flips them, yeah. So we're going to get that, right? There's our answer. X is greater than 2 and less than 8. So if I graph this guy, what do I get? Oh, that's supposed to be less than or equal to, isn't it? Yep. Closed endpoint at 2. Where's the other endpoint? 8. And I'm going to connect everything in between. So how would I say that with interval notation? Bracket 2, 8 parentheses. Okay, good. So last one is one step, but there's one real important thing I want to show you here. What's the only step to get x by itself? Divide by -2. All right. Okay, so that cancels the -2's. I'm going to get a positive, -4 divided by -2 is +2. I get an x in the middle, and 8 divided by -2 is -4. What do I have to remember to do? Flip the inequalities. Okay, so do you think that's okay to leave it that way? No. It's not. It's not. There's something, it's not simplified, and here's why. If I graph that, look at what the graph looks like. Everybody agree I want the values of x that are greater than -4, so I'm going to put an open end point at -4 and graph to the right. I want the values of x that are less than or equal to 2, so I get a closed end point at 2, and I'm going to graph to the left, and those graphs would intersect between the two. Okay, what's wrong with that? Like if I write that with interval notation, I've got my comma in the middle, I've got a -4 with parentheses on the left, and I've got a +2 with a bracket on the right. So what's wrong with the way I wrote that 3-part inequality? Yeah, it's backwards. Backwards, right? The inequalities are opening in the wrong direction. I've got the smaller number on the right, bigger number on the left. That's backwards. It doesn't fit interval notation. So what do we have to do to this thing to make it right? I got to take the whole thing and twist it around. You've got to be careful when you do that because everything gets rotated. It's like I write this thing on a piece of glass and then I rotate the glass around an axis in the middle where it's going to rotate around that thing, right? So this inequality right here, x is greater than -4, ends up being on the left. But it needs to say the same thing. It needs to say x is greater than -4, which if we read that starting with the x, isn't that what that says? Yeah. Everybody agree? Give me thumbs on that. Does that make sense? Does everybody agree that says x is greater than -4? Yeah. Okay. And the other part, x is less than or equal to 2, now goes to the right. So that's the way we would have to write our answer. Everybody see that? Okay, I'm going to shut up. You guys can work, get a full work day tomorrow. See if you can get a couple problems done today. The assignment's up there. Yeah, you bet. Take the pass.